Today we're going to talk about the wildfires across the globe and what the effects have on all the globe. So what happened in California? 2018 marked the deadliest and most destructive wildfire season ever recorded in California history. The past decade has seen half of the state's 10 largest wildfires, and 7 of those 10 have been the most destructive fires. There's been a total of over 8,000 fires were burning in an area of 1,893,913 acres. By August, California had spent $432 million on fighting fires, and by May of 2019, insurance claims related to the fires had reached over $12 billion. Over the past 5 decades, these fires have increased in size by roughly 800%. Since the 1990s, over 43% of the residential buildings were constructed in areas where the wildfires started. Some areas house more than 80% of the new residents. Therefore, there's new homes that are able to burn and more buildings being destroyed. By November of 2018, strong winds started around another round of destructive fires across the state. This included the Woolsey Fire and the Camp Fire, which killed at least 85 people, and there's still 2 that are unaccounted for. Remember, all it takes is a spark. Deadly wildfires, such as the ones that raged through California, can begin with a simple downed power line, a tossed cigarette butt, or a flat tire. So who's to blame for all these fires? In earlier history of the Earth, nearly all wildfires were caused by lightning strikes. Sadly, today, humans are mostly responsible for the majority of wildfires started in modern times. But humans were not the direct cause of the fires in California. There were many different factors that led to the fires of California. The first contributor to the fires was an increase in dead tree fuel. In fact, by December of 2017, there was a record of 129 million dead trees in California. The second cause was the compounding atmospheric conditions linked to global warming. So what are the effects of dead tree earth to our Earth? Over the course of several decades, after a large wildfire, emissions from decomposing dead wood surpasses the direct emissions of the fire itself. Although at the same time, new growth in burned areas starts to take on CO2 from the atmosphere and store it. Fires also change the reflectivity of the land in a process called albedo. As burned forest areas start to regrow, the light-colored patches of grass and shrubs come in first. Then, because they reflect more solar radiation, they can have a cooling effect until the vegetation thickens and darkens again. CO2 is a major issue. Although the exact quantities are different to calculate, scientists believe wildfires emitted 8 billion tons of CO2 per year for the last 20 years. Extreme fires emit huge amounts of CO2 in a short amount of time. The blaze in California's wine country of 2017 was estimated that it released as much CO2 in 1 week as all the cars and trucks did in an entire year. That's a lot of CO2. According to the NOAA scientist, a very large and hot fire that destroys 500,000 acres can emit the same total amount of CO2 as 6 large coal-fired power plants do in 1 year. What about particle pollution? Although with CO2, wildfires produce many other volatile organic particles called aerosols, including substances like carbon and gases. Wildfires emit 3 times more fine particle pollution than previously estimated. Megafires, like the ones in California, Australia, and the Amazon, intensify these emissions and send the pollutants higher into the atmosphere. So what is the link between climate change and wildfires? Well, California has warmed up 3 degrees higher Fahrenheit. This warmer air sucks water out of the plants and soils, thus leaving the trees, shrubs, and grasslands ready to burn. Each degree of warming causes way more fire than the previous degree of warming did. Even during a wet year, an intense heat wave can choke forests out as if the rain never fell. Another factor is the change in precipitation. California's dry season has been lengthening. Each extra day of dryness increases a plant's susceptibility to burning. Lastly, climate change is caused by an increase of greenhouse gases such as carbon dioxide. Greenhouse gases build up in the atmosphere, trap heat, and warm the planet. Once the fire is lit, humans can't do much about the greenhouse gas emissions effect. But time is running out, and every ton of CO2 without strong climate policy changes, and industrial emissions are likely to triple in this century. Scientists are urging societies to adopt strong policies to prevent regions of lower carbon grasslands and shrubs. So the effects of global warming are that the soil gets dried out and the vegetation. So no matter how the fire was started, global warming is helping to expand it across the land at a quicker rate. Next, we'll move on to Australia and what happened with the fires that were there. Australia first experienced a terrible drought for 13 years from 1997 to 2009. Right after that, 2 years of crazy rainfall happened from 2010 to 2011. The wet periods caused plants to grow back and brought a lot of nature back to life. But when they ran into the heat problems again, that dried out with all the different plants that grew. It was much easier for these fires to spread. So what is the Hadley cell's effect? The Hadley cell is creating what they call a subtropical ridge. These high pressure ridges are created when hot air rises from the equator towards the poles. This high pressure ridges make it so that there's less rainfall in these areas. Here's an example of the Hadley cell and how it works. So the dangers are that the fires are very deadly, and if they are big or bad enough. Australia was very unlucky because the fire spread throughout millions of acres of land. About 24 people were killed in the scorching fires that were recorded, and they've estimated that about 500 million animals were also killed. So what about climate policies in Australia? Australia is ranked nearly last in the climate change policies because every time they get a change of government, the environment gets worse. Australia became the first in the world to repeal a carbon tax in 2014. Liberal Party leaders continue to say they don't need a change in the climate policies, even though the brush fires, forest fires, and any other fires continue to burn fiercely. They are trying to create more coal mines for fossil fuel expansions. The predictions for Australia are that scientists believe that because of the temperature increases in southern Australia, the chances of fires on extremely hot days will rise from 5 to 100% by the year 2050. The fire season in Australia will expand into the fall and spring due to the temperatures rising and making the climate drier. Hot, dry conditions of the forest will help the fires make comebacks for later years, and it's going to be very hard to stop them at that point. They need constant rainfall for the span of a few weeks to help decrease the chance of more fires. Next, we're going to move on to the Amazon and what happened in the fires that were created there. Fires were causing concern in June and July, and by August, the smoke had traveled thousands of kilometers away and made Sao Paulo's sky dark during the midday. Here's a picture of the Sao Paulo's sky during the midday. 80,000 separate fires were burned in Brazil, with 40,000 of these in the Amazon rainforest. A total of 9,060 square kilometers of rainforest was lost, and there was a 77% increase from 2018 in the number of fires. There were human causes that were to blame for the Amazon fires, such as a slash and burn method to make room for farming, livestock, and mining. Deforestation peaked in the 1990s and the early 2000s. So Brazil put into place regulations on the development of agricultural land. In 2012, annual deforestation was 80% lower than the average rate between 1996 and 2006. Brazil elected their new president in January of 2019, and he is often blamed for encouraging deforestation from agricultural development in the Amazon region and reducing environmental protections. Also, illegal logging was no longer being consistently punished. In April, May, and June, over 700 square miles of forest have been chopped down, according to the agency, about 25% more than the year before. The environmental causes of the fires were that Amazon's dry season occurred around June through December, and that dry season coincided with the increasing amount of deforestation and slash and burn method. Therefore, the fires got out of control and ran rampant. As global temperatures continue to rise, this increased the risk of more fires. So what about Amazon's carbon sink? The forests occupy nearly a third of the land surface on our planet and provide a foundation for nearly all terrestrial ecosystems. An area equal to 27 soccer fields of the Earth's forests is destroyed every minute. Approximately 18.7 million acres of forest are felled annually. In the last few months, Brazil has opened even more of the precious remaining Amazon to resource extraction. Sadly, the inferno raging in one of the last few treasure troves on the planet is not an isolated ecological disaster. Wildfires are consuming the wilderness in Siberia, Indonesia, Central Africa, and Alaska. And fires are not the only cause, however. Our forests are being cut down at an unprecedented rate. Wildfires have broke out across 5.5 million acres of the Amazon forest in 1 month. The dry weather, wind, and heat has burned up an ecosystem already under threat from an agriculture, logging, and mining. The Amazon rainforest is the largest carbon sink on the land. Up to 25% of the world's carbon dioxide can be absorbed in the rainforest's biomass. So what are the general effects of the Amazon wildfire? The Amazon produces 6 to 20% of the world's oxygen. There's a dieback process in which climate change speeds up the loss of trees and changes the landscape. This could start with just some of the Amazon's destruction. This tipping point could lead the Amazon to devolve into a barren, savanna-like landscape that not only fails to produce oxygen, but could cause the release of 140 billion tons of carbon stored into the atmosphere. Rising global temperatures also threaten the future of the remaining trees in aiding the planet. A 2000 study found rising temperatures could stop trees in the Amazon from absorbing oxygen by as early as 2050, and they could start to emit carbon instead. What about Amazon's wildlife? What happened to them? Amazon contains 1 in 10 known species on Earth, including 40,000 plant species and more than 400 mammal, 300 reptile, 400 amphibian, and 3,000 fish species. These animals are native to the Amazon, and they're not adapted to cope with the blazes. As hollow trees standing began to burn, mammal and bird species that nest in their cavities were displaced with nowhere to go. Destruction of these trees with the fruits that serve as their food source resulted in the reduction of the number of species of birds, primates, and animals that fed on them. What was Amazon's response to all the fires? Brazil's government officially ordered on August 29, 2019, the prohibition of the use of fire to clear land for the crops and the cattle grazing in the Amazon region for 60 days. The law published in the official gazette is aimed at avoiding new outbreaks of fires at a time when authorities are starting to control the blaze that have torched the planet's largest rainforest over the past 3 weeks and alarmed the international community. This decree was signed following increased pressure from the international community, and Bolsonaro also dispatched over 44,000 Brazilian troops and allocated funds to fight these fires. Overall, what ends up happening to the ice sheets in the Arctic from all these blazes that are around the globe? The skies will eventually clear, but all that smoke just never disappears. The CO2 will heat the atmosphere for centuries, and the methane for a few decades. Aerosol and other particles begin to spread out over our northern hemisphere oceans and continents. Tiny remnants can also affect the climate when they land on the snow and Arctic ice. Although the indirect effect of the wildfires melting the Arctic ice is difficult to measure, there is growing research that suggests wildfire soot will continue to be a key factor in the accelerated melting of the Arctic in decades to come. Thanks for watching this video. We hope you really enjoyed it.